Hey, what's up everyone? I hope you're doing well today. I wanted to make a video on a couple of different ways that you can live reload your microservices when you're developing locally in Go. In my project here, I've got a couple of different applications running. I've got a API server that's listening on port 5000, and I've got a worker that's polling for SQS messages and waiting to process them and do some work. However, currently in my application, if I were to make any code change, this is not reflected, and I have to manually restart each of these processes in order to pick up the code changes. And this is where a tool like Air comes in. This is a super popular Go library or Go command line tool that allows you to live reload your applications, and I'm sure a lot of you are already familiar with this. However, when you set this up initially, it is configured to only work with one binary or one process. So what I'm going to do is show you how you can easily set this up to work with multiple processes or multiple microservices that you'd be running locally. So what we're going to do first is run our air init command. This will set up our air.toml. And you can see here we've got this bin field and this CMD field. So this controls how air is going to be rebuilding our executable. So right now it's only set up to run for one executable here, but I've actually got two different apps I want to run, or two different microservices. I've got this API server and this worker. So how would I set this up so that I could automatically pick up any changes for both of these processes that are running? Well, what we can do is just go ahead and comment out both of these. And what I've got here is a make file that I'm using, and it basically is just helping me with basic tasks that I need to run in my application. So what we can do is just go to the Air GitHub page here, and they've got a command that allows us to specify specific properties on our config. So I'm going to go ahead and copy this, and I'll do a command that is just called API. Okay. And I'm going to modify this to run my API application. Okay, and now what I can do is do the same thing for my worker process. So you can see that I've created these two commands, and these are updated so that I will generate a binary into the bin directory, and it'll create these executables from these two apps that I have here. Whoops, I had a typo here. So I had the quote starting right there. It needs to be right here. But you'll notice in the documentation here, it says if you want to config build command and run command, you can use the following command without the config file. But I actually still want a lot of the information in the config file. So for example, there's this pre command. Say I wanted to run some command before my app starts. So I can just say echo hello world as an example. I still want to have that config file as my base config and then be able to override this command to run for several different binaries. So what I can do is actually add the -c command and specify my config here. And then when we rerun the API server, we can see that it executed that pre-command. So it's echo hello world, and now my API server is running. Let's do the same thing for the worker. Let's kill it. And we'll go ahead and clear this, make worker. And you can see that it also executed this hello world command. So let's go ahead and take a look at our config, and let's modify this again. Now we can see that it's rebuilt the application and all of this is refreshed. It also reran that pre-run command. And that's happened for both of these. So that's a super cool way to configure this so that you can run multiple processes, but still get live reloading if you make a change to a common dependency in your code. So now I want to walk you through an arguably easier way to do that same thing. There's another tool called Task. You can find it at taskfile.dev. And it's basically a task runner build tool that is written in Go. And it's sort of like a replacement for make or a make file. You actually configure a YAML file, and then you define your different tasks and the associated commands that you want to run. The difference here is that we have a really cool feature where built in, we can watch tasks and specify certain sources. So here I could specify watch equals true and then specify all Go files. And if there's any change to my Go source code, I can rebuild this task automatically. So let's go ahead and try this out. Okay, so I'm going to go ahead and kill the currently running processes. And what I'm going to do is create a task file. And I'm going to copy this YAML here. I don't need this. And what I'm going to have here is just my API task. And we're going to do something very similar here. We're just going to do go build. And then we'll go ahead and execute it. So now we're building the binary using our app here, and then we're executing it immediately. We could technically split this up into two separate commands, but for simplicity now, we'll just go ahead and make it one. I forgot the -o here. Okay. So now I can go ahead and just run task API. And let's go ahead and make a code change. Okay. Run it again. We can see that it's a little bit slow, but what we can do is set an interval here, and let's just make it 1 second. And I'll go ahead and restart this to pick up the new task file. It's a little bit snappier now for picking up these changes. Okay, so let's go ahead and add our worker as a command here. Okay, so I've now added a worker task. So all I have to do is say task, API, and then I can specify the worker task as well. And I can actually run both of these in the same terminal or separate terminals if I want. Okay, so I just made a code change, and you can see that I've got logs for both the API server and the SQS worker. Depending on how noisy your logs are, you may not want to have these in one terminal, but it's still a cool option to have. Say you had 10 microservices that you needed to run. You could configure them all as tasks and then create a single task that executes all of them. You could run your entire system locally and have it respond to changes that you make live. So this is actually a really cool tool and a pretty good alternative to Air if you want to get this task runner type of feature as well. So that's it. That's all I had for you guys today. If you found this video useful, please consider giving it a like and consider subscribing as well. Until next time, I'll see you guys. Take care.